Somewhere out there, beyond the glow of the nearest galaxies and the polite certainty of textbook cosmology, there may be a mistake so large it changes everything. Not a small error, not a rounding issue, a structural error, a cosmic misreading. What if the place we inhabit is not a representative patch of the universe at all, but a strange deviation in the grand pattern, an abnormal region that bends the numbers before we even realize we are looking through it? If questions like that pull you toward the edge of what science can explain, subscribe to Beyond the Universe, because some discoveries do not hand you answers. They quietly rearrange the ground beneath your feet. And once that ground starts to move, the universe we thought we knew begins to look less like a finished map and more like a document filled out from the wrong room. For most of modern astronomy, the universe has behaved like a vast, honest thing. We point our instruments outward, collect the faint language of light, and assume the cosmos is speaking from a place of rough fairness. The further we look, the more we average out the noise, the more the universe is supposed to reveal its general rules. But what if the region around us is not average? What if our measurements are being shaped by a local condition so subtle that it hides in plain sight, like a floor that appears level until you realize the whole building is tilted? Then the problem is not merely that our calculations are incomplete. The problem is that the universe may be telling the truth from a distorted position, and we have mistaken the distortion for the whole story. That possibility sounds almost insulting at first, as if the cosmos itself were playing a trick on us. But the deeper you go, the less absurd it becomes. In astronomy, location is never innocent. Every measurement comes from somewhere. Every observation is made inside a neighborhood, not outside the universe looking in. And if that neighborhood is unusual enough, if it is underfilled with matter or stretched differently, or embedded in a larger pattern we have not fully recognized, then even the expansion of space can seem to behave differently depending on where the observer stands. In that case, what we call the expansion rate of the universe may not be one clean number at all. It may be a number filtered through local geography, like trying to judge the speed of a river while standing in a quiet eddy. The unsettling part is that this is not the kind of idea that appears only in philosophical speculation. It emerges from the machinery of observation itself. Astronomers measure distant supernovas, cosmic microwave background patterns, galaxy distributions, gravitational lensing, and all the subtle fingerprints that light leaves behind as it crosses billions of years. Then they compare the expansion inferred from the early universe with the expansion inferred from the nearby universe, and the answers do not sit comfortably together. The gap is small enough to seem technical, but large enough to be haunting. It is a discrepancy that refuses to go away. And once a discrepancy survives this long, it stops looking like a typo and starts looking like a clue. To understand why this matters, you have to picture the universe not as a uniform fog of stars, but as an immense architecture built from invisible scaffolding. Galaxies are not scattered randomly like confetti. They gather along long filaments, dense threads of matter stretching across dark space, while enormous empty regions open between them. The whole structure resembles a city seen from orbit at night, except the illuminated districts are galaxies, the roads are filaments of dark matter, and the black provinces between them are not mere absence, but engineered silence. The universe is not filled evenly. It is organized. It has neighborhoods, highways, borders, and vacancies, and those vacancies are not trivial. They are among the most important features of cosmic geography. Imagine standing inside an enormous frozen lake at dawn. From a distance, it seems smooth, almost perfect, but once the light catches it, you notice hairline fractures spreading through the ice, branching into delicate geometry. The cosmos is like that, except the cracks are not signs of collapse. They are the structure itself. Matter gathers where the fractures meet. Voids open where the ice has thinned. Gravity sculpts the pattern over eons, and the universe slowly becomes a lattice of tension and emptiness. So when we say empty space, we are speaking carelessly. Cosmic emptiness is not a blank page. It is a page with invisible pressure marks, a page whose arrangement can influence everything written on top of it. This is where the cosmic web enters the story, not as a poetic phrase, but as a real framework of large-scale structure. Vast filaments connect clusters of galaxies like the ribs of a skeleton, too immense to be imagined at once. In the spaces between them are cosmic voids, regions with far fewer galaxies than expected, regions that can span hundreds of millions of light years. They are not absolute nothingness. They still contain tenuous matter, radiation, and the faint architecture of gravity. But compared with the bustling nodes of the web, they are almost deserted. If the universe were an empire, these voids would be the remote provinces where roads are rare, signals are weaker, and the map itself starts to lose confidence in its own scale. And that is exactly why the possibility of living inside a large, underdense region is so provocative. If our cosmic neighborhood is less crowded than average, then the light arriving from distant objects has been traveling through an environment with different gravitational conditions than the one assumed in standard calculations. Expansion could appear faster or slower depending on the density profile around us. The observed sky would still be real, but not necessarily representative. A local deviation would not destroy cosmology outright. It would simply mean that we have been reading the universe through a lens shaped by our location, and once location enters the equation, certainty begins to thin. For decades, cosmology has relied on the assumption that on sufficiently large scales the universe is homogeneous and isotropic, that it looks roughly the same in every direction and from every place. This is the Copernican spirit extended into space. Not only are we not the center, we are not supposed to be in a special patch either. That principle is elegant. It is also deeply reassuring. It tells us that our measurements can be generalized, that our corner of the cosmos is ordinary enough to speak for the whole. But if that principle is even slightly broken on immense scales, then the confidence with which we infer the age, composition, and future of the universe begins to soften. The strange thing is that the universe has never fully agreed to be simple. The farther astronomers have looked, the more a familiar tension has persisted, the Hubble tension. Different methods for measuring the expansion of the universe produce incompatible values. Early universe measurements anchored in the cosmic microwave background point toward one rate. Late universe measurements based on nearby distance ladders and supernovae point toward another. The mismatch is not catastrophic in a dramatic, cinematic way. It is worse than that. It is persistent, disciplined, and stubborn. It sits in the data like a locked door, and every year it remains, the possibility grows that something foundational is being missed. Now imagine for a moment that the disagreement is not a flaw in the instruments, nor a hidden calibration mistake, nor an exotic new particle waiting patiently in the shadows. Imagine instead that the universe around us is not average. Imagine that the section of the cosmic web we occupy sits inside a broad underdensity, a region where matter is slightly sparser than the cosmic mean. In such a scenario, local gravitational dynamics could influence the way nearby space expands relative to the deeper background of the universe. The result would be a kind of cosmic optical illusion. From our position, expansion appears calibrated one way, while the universe on larger scales obeys a subtler rule. This is where ordinary science starts to feel almost conspiratorial, not because it is irrational, but because reality itself begins to resemble a system that hides its own asymmetries. A room can seem level until you place a marble on the floor and watch it roll. A map can appear complete until you discover it was drawn from one district of the empire and then declared universal. If our region of space is atypical, then we may have done something equivalent. We may have confused the temperament of the neighborhood for the law of the continent. We may have mistaken a local slope for the shape of the whole terrain, and the universe gives us very little reason to be complacent. Voids are not rare decorative features. They cover a significant fraction of cosmic volume. They affect the movement of galaxies, the bending of light, and the statistical character of large-scale observations. Even if a massive local underdensity does not fully explain the Hubble tension, its existence forces an uncomfortable question. How much of what we infer about the cosmos depends on the assumption that our region is typical, not just roughly typical, statistically typical, cosmologically typical? If that assumption weakens, then every answer derived from it begins to feel less like a conclusion and more like a conditional statement. The deeper danger is not simply numerical disagreement, it is conceptual instability. Standard cosmology rests on a delicate chain. The universe is broadly uniform at large scales. The laws of gravity and expansion behave consistently. Local departures average away. Distant observations can therefore be used to infer global truth. But if our position lies inside an unusual region, that chain no longer feels like iron. It feels like glass. It can still hold, but now you can see the stress lines. And once you notice the stress lines, the question is no longer whether the glass will break. The question becomes where the first crack is already forming. One reason this idea unsettles people is that it threatens a hidden assumption many of us carry without noticing, that the cosmos is not playing favorites. We like to believe that our vantage point is irrelevant, that the universe is too vast to care where we stand. But observation is never free of context. Your eyes are not floating outside reality. They are embedded inside it, receiving signals filtered through a particular lineage of matter, motion, and local structure. The universe does not hand you a pure view, it hands you a view from somewhere. And if somewhere happens to be strange, then your certainty is strange too. Consider how a sailor at sea might underestimate the curvature of the Earth if he only ever judged distances by the horizon in one direction, under one sky, from one deck. The world would still be round. The mistake would not change the planet. It would change the observer's confidence in what the horizon means. That is the core anxiety here. The universe may be perfectly lawful and yet partially hidden by the conditions of our location. Our measurements could be accurate and still incomplete in the most dangerous sense. They may be accurate about our neighborhood while incomplete about reality as a whole. The possibility becomes even more charged when you think about dark matter, the unseen scaffolding that shapes the growth of galaxies and clusters. We do not observe it directly, yet its gravitational fingerprint is everywhere. It threads through the cosmic web like an invisible frame supporting a curtain. If the distribution of ordinary and dark matter around us differs from the expected average, then the entire local cosmic environment could be skewed. That skew would not announce itself with fanfare. It would whisper. It would alter galaxy motions by tiny amounts, tweak lensing patterns, nudge expansion measurements, and slowly, patiently, produce a universe that appears to be one thing from our seat and another from farther out. This is what makes the anomaly hypothesis so compelling. It does not require the universe to violate physics. It only requires the universe to be uneven in a way we had not fully appreciated. Nature is not obligated to be flat and boring just because our equations prefer elegance. The cosmos can be lumpy at the deepest scales we can survey, and those lumps can matter. A region of lower density can create an apparent boost in measured expansion, because gravity and local flow patterns matter when distances are inferred from light. If enough of that pattern surrounds us, the result may be a subtle but persistent distortion in the way we read the cosmic clock. There is something unsettling about the word local in this context. It sounds harmless, temporary, small, but in cosmology, local can still mean hundreds of millions of light years. Local can mean a volume so immense that every human civilization to date would fit inside a dust mote compared with it. Local can mean a neighborhood so wide that its walls are invisible and its edges are conjecture. When scientists speak of a local underdensity, they are not talking about the empty corner of a room. They are talking about a volume of space large enough to alter the meaning of the room itself. And once you allow that scale of distortion, you begin to see why the issue reaches beyond the Hubble tension. A local anomaly does not merely affect one measurement, it challenges the assumption that all cosmological measurements can be straightforwardly reconciled inside a single tidy model. It asks whether the lambda CDM framework, for all its success, may be leaning on an idealization that smooths over real complexity. The model may still be useful, even powerful, but usefulness is not final truth. A roadmap can help you cross a continent while still failing to show the storm front gathering in one valley. The universe may be like that, mostly well described, but not evenly so. At this point, the story stops being only about astronomy and becomes something stranger. If the local universe is unusual, then what exactly do we mean by the universe in our measurements? The word begins to split. There is the observable universe, the horizon of all light that has reached us. There is the larger cosmic ensemble, inferred through theory. There is the effective universe around us, the region whose structure influences our observations. And then there is the universe in the absolute sense, if such a thing can be meaningfully spoken of at all. Each layer feels more abstract than the last, and yet the one we live inside may be the least representative of the whole. That is the first philosophical shudder. Perhaps reality is not evenly distributed in its own visibility. Perhaps the cosmos does not reveal itself uniformly, but with local accents, regional dialects, hidden emphases. We imagine laws as if they were spoken in a single voice everywhere. But maybe what we call universal law is a translation from a particular place. Maybe our equations are not false so much as incomplete in scope. Maybe they are excellent notes from a classroom in one district of a much larger city, later mistaken for the constitution of the entire civilization. The Copernican principle once helped dethrone the human imagination. It said we are not at the center, but what if the next stage of humility is harder? What if we are not even in a typical region? That would not make us cosmically special in any flattering sense. In fact, it would be the opposite. It would mean our perspective is compromised by accident. Our observations would still matter, but they would carry a caveat stamped into the fabric of space itself. These results are local, handle with caution, and that caution would seep into everything from distance estimates to the inferred rate of cosmic growth. Now the emotional texture changes. At first, the anomaly seems like a puzzle. Then it becomes a problem. Then it becomes a question of trust. Can we trust the sky we are using to calibrate the universe? Can we trust the background assumptions stitched into every cosmological inference? Or are we looking at a grand, elegant mirage created by a region that is just different enough to deceive us? The unsettling part is that no single image of the sky can settle it. The sky can only show us what has reached us, and what has reached us has already traveled through the local architecture we are trying to understand. This is why the debate around cosmic underdensities matters far beyond niche astrophysics. If the anomaly is real and large enough, it could explain part of why expansion measured nearby seems faster than expansion inferred from the early universe. If it is not large enough, then something else must be missing. Either way, the cosmos is telling us that the clean story is under pressure. There is a discrepancy in the chain of reasoning, and each attempted repair seems to open another seam. The measurements do not just disagree, they disagree in a way that exposes the fragility of the assumptions beneath them. Think of a long bridge built across dark water. From the shoreline, it looks symmetrical, but walk far enough toward the center, and you may discover that one half is anchored to slightly different supports than the other. The bridge still stands, but now your understanding of its design has changed. That is where cosmology finds itself. It is not collapsing. It is being revealed as more conditional than it first appeared. And if the supports beneath our local section of the cosmic bridge are unusual, then the whole experience of distance, expansion, and scale becomes something like crossing a structure whose geometry cannot be fully guessed from the first steps. The more you think about it, the more the issue becomes intimate. Every distance ladder relies on a chain of assumptions, calibrations, and reference points. Every ladder has rungs. Every rung depends on the strength of the one below. If one local region biases the lower rungs, the effect can travel upward into the final estimate of the universe's expansion. This is not a trivial concern. It is the difference between reading the cosmic script as written and reading it through a lens warped by nearby conditions. A slight bias at the base can become a philosophical tremor at the top. And what happens if the universe really is uneven enough to matter this much? Then homogeneity, which was once a comforting approximation, may have to be treated as a more fragile statement than we wanted. Not false, perhaps, not abandoned, but less absolute. The universe on the grandest scales might still be statistically smooth while containing enormous variations that matter precisely where we stand. That distinction is everything, because a universe can be homogeneous in the limit and still locally deceptive. It can obey large-scale order while hiding regional anomalies large enough to change the meaning of our measurements. This is one of those ideas that becomes more disturbing the longer you sit with it. If the universe is only statistically uniform when viewed from enough distance, then our knowledge is always delayed by scale. We do not see the whole pattern at once. We see the close-up first, and the close-up can mislead. We are like someone trying to understand a forest by standing inside one grove during fog. The trees are real, the density is real, but the overall shape of the forest remains uncertain until the fog lifts, and perhaps the fog is not in the air at all. It is in our position. A beautiful, maddening consequence follows. Reality may not simply be discovered, but partially negotiated with the observer's location, not in a mystical sense, in a physical one. The universe does not bend truth to our wishes. It bends the signal according to the path it takes to reach us, and if that path crosses a large-scale anomaly, then the data carry the signature of that crossing. This does not mean reality is subjective. It means access to reality can be condition-dependent. That is a much more difficult thought, because it leaves objectivity intact while making certainty feel provisional. There is an older instinct in science that resists this. We want the cosmos to be clean at the largest scale, because cleanliness implies legibility. But the universe has never promised legibility. It only offers consistency. Consistency can still produce complexity. A field of wheat can look uniform from a distance and still contain irregular growth in every row. The laws remain the same. The arrangement varies. Perhaps our region of the cosmos is one of those irregular rows, lawful but not representative. If so, then the problem is not that science is wrong. The problem is that science must now account for geography on a scale too large to ignore. The possibility also changes how we think about cosmic time. Expansion is not just a rate, it is a narrative. It tells us how the universe has unfolded from the hot early state to the structure we see today. If local density affects the inferred rate, then our story of the universe's past and future may have been narrated with a regional accent. That does not make the story fictional, it makes it perspectival. The universe may be older, younger, or differently evolving than some estimates suggest, depending on whether our measurements are corrected for local structure. Suddenly, the calendar of everything becomes less stable, and then comes the quiet horror of scale. A human life is brief enough to mistake any stable sky for eternity. Civilizations rise, instruments improve, and still the cosmos remains mostly beyond our sensory reach. That is why a local anomaly matters so much. It exploits the gap between what we can detect and what we can assume. It hides in the difference between a few percent and a fundamental shift. It can make the universe feel almost normal, while quietly steering our interpretation of every astronomical clue. The deception is not malicious, it is architectural. So perhaps the right question is not whether we live inside a cosmic void, but whether we inhabit a region of space whose difference is large enough to reweight the entire cosmic ledger. Imagine trying to estimate the value of a continent by standing on one island and looking outward through sea mist. The result may still be useful, it may even be impressively accurate, but it cannot be the final word unless you know how unusual your island is. Our cosmic island may be smaller, emptier, or less dense than the surrounding ocean of large-scale structure. If so, then every conclusion about the continent must carry that uncertainty with it. And maybe that is the real revelation. Not that we are at the center, not that we are special, not that the universe is broken. The revelation is harsher and subtler. The place from which we ask our deepest questions may itself be atypical enough to distort the answers. That means knowledge is not just a matter of better telescopes and sharper equations. It is also a matter of understanding the hidden conditions of our perch. Without that, we may be solving for the universe while unknowingly living inside one of its exceptions. The final implications are not comforting, but they are magnificent. If our cosmic neighborhood is anomalous, then the clean separation between local and global may not be as clean as we hoped. If homogeneity is only approximate over the scales we can practically test, then some of our most confident cosmological conclusions may be running on assumptions we have not fully earned. If the Hubble tension is partly a sign of local bias, then the universe is not merely asking us to refine a number, it is asking us to rethink what it means to measure a whole from within a part. And if that sounds like the beginning of a philosophical crisis, that is because it is, not a crisis of despair, but of proportion. We have spent generations learning how to place humanity in the cosmos. Not central, not privileged, not the measure of all things, but perhaps there is a deeper lesson waiting behind that lesson. Perhaps our true challenge is not to accept that we are small, but to accept that smallness can still distort vision when the stage is large enough. Even a tiny region can bend interpretation if the surrounding structure is vast, uneven, and only partially visible. So here we are, standing inside a universe that may not be as uniform as our models prefer, inside a region that may not be as ordinary as we once believed, inside measurements that may be honest and yet incomplete. The sky above us remains beautiful, but beauty is not the same as simplicity. The galaxies continue their silent drift. The cosmic web continues to stretch through darkness. The voids remain open, patient, and strangely influential. And somewhere within that architecture, our local section of space may be whispering a correction to everything we think we know. If that correction is real, physics has a problem, not a fatal one, a profound one. Because then the universe is not merely larger than our models, it is structurally trickier. The assumptions that made cosmology feel settled become conditional, and the confidence with which we read expansion, density, and distance must be tempered by an awareness that our neighborhood could be a poor sample of the whole. We would not be losing science. We would be discovering the cost of assuming that one place can stand in for everywhere. And so the mystery remains open, larger now than when we began. Maybe the expansion of the universe is not what we thought. Maybe our corner of space is unusually sparse. Maybe the Copernican principle survives only as an approximation, not a guarantee. Or maybe all of this is a warning that reality, when seen from inside it, can never be fully separated from the local structures that shape the view. The cosmos may be lawfully arranged, and yet our reading of it may still be bent by the region we inhabit. That is the unnerving possibility. Not that the universe is lying, but that it is speaking from a distance we have not yet learned to correct for. And when you sit with that long enough, the silence gets deeper, because the question is no longer just what the universe is made of, or how fast it expands, or whether the numbers line up. The question becomes whether our entire picture of existence has been assembled from a vantage point too peculiar to trust completely. If so, then every answer is a doorway, and behind that doorway is another room, and behind that room is a corridor we have not mapped yet. The universe does not end at the edge of our measurements. it begins to reveal its true complexity there. That is why this anomaly, if it exists, matters so much. It is not a curiosity on the margins of cosmology. It is a reminder that the cosmos may contain regions that quietly alter the logic of observation itself. We thought we were measuring a universal law. We may have been measuring a law filtered through place. We thought the sky was uniform enough to trust. We may have been trusting a sample that was never as ordinary as we imagined. And once that idea enters the mind, it does not leave cleanly. So the next time you look up at the night sky and see that calm scatter of distant light, remember that calm does not guarantee simplicity. Beneath the beauty may be structure, beneath the structure may be asymmetry, and beneath the asymmetry may be a local condition shaping what we think the universe is doing. We may be living in a region that is just different enough to confuse the answers. We may be inside a cosmic exception, large enough to feel like the rule. And if that is true, then reality is not less real. It is more complicated than our first draft of the cosmos ever allowed. For now, the mystery stands exactly where the best mysteries should stand, unresolved, persuasive, and a little too large for comfort. The universe may be expanding as we speak, but the confidence with which we describe that expansion may depend on where we happen to be in the cosmic landscape. That is a sobering thought, because it means our best measurements might still be local testimony dressed as universal truth. And if the universe is teaching us anything here, it is this. Sometimes the hardest thing to measure is not the cosmos itself, but the strange, quiet place from which we are measuring it. This realization does not call for despair, but a new kind of curiosity, one that embraces uncertainty as a signpost, not a failure. If the cosmos is whispering that our vantage point shapes what we see, then the task before us is not to escape that vantage point, which is impossible, but to map its contours with greater care, to understand the subtle distortions woven into our local cosmic fabric, to learn how to peel back the neighborhood's influence from the signals arriving from deep time and space. It is a challenge unlike any before because it asks us to include ourselves, not as dispassionate observers, but as embedded participants in the unfolding story of the universe. In practice, this means developing new methods, new perspectives that cross the border between the local and the global. It means coring deeper into vast scales of space and time to look for fingerprints of bias, searching for connections between local structure and universal inference. It means cross-checking expansion rates across many directions and scales, looking for signs that the anomaly stretches in specific ways or masks itself in subtle signals. And it means accepting that the final picture may be more patchwork than smooth, more a tapestry of regional dialects than a single cosmic language. These efforts are already underway, gathering momentum like a new tide raising the boat of cosmology. Large surveys map millions of galaxies across the sky. Advanced simulations reconstruct the growth of structure from matter and energy's primordial soup. Observatories both on Earth and in space push the envelope of measurement precision, resolving more distant supernovae and measuring cosmic background radiation with ever finer clarity. Each data point chips away at ignorance. Each anomaly tested tightens the noose on uncertainty. But no matter how sophisticated our tools become, the essential problem remains. We stand inside the system we want to understand. This self-reference is an age-old challenge in science and philosophy. Measurement is always partial. Observers, by their nature, affect what can be observed. Reality stubbornly refuses to be scanned from outside itself, at least not in any direct sense we can perform. And the cosmic neighborhood is no exception. The voids and filaments around us are real structures with real effects, yet their shadows across our measurements are subtle, hard to separate from noise or complexity. Untangling that knot is one of the great frontiers of current cosmology. And yet, there is a strange beauty in this complexity. The universe, vast and ancient, is revealing layers of subtlety that require us to rethink our place not only physically, but epistemically. It reminds us that knowledge is a process, not a static achievement, that certainty is layered, sometimes fragile, and often provisional. It reminds us that every answer carries within it the question of how it was arrived at, and whether the observer's seat was ordinary or exceptional. Our cosmic story is therefore a story about both the universe and ourselves, how each shapes the other in dance. So as you watch the galaxies spin and the cosmos expand across measureless time, consider the possibility that we are not simply floating in an average sea of stars. Instead, we may be moored within a deep, quiet pocket, a cosmic niche whose difference colors the entire picture we call reality. This does not shrink the universe. It expands the mystery, opening new doors for exploration, questioning, and wonder, and it reminds us that to go beyond the universe, we might first need to look more carefully at the one we inhabit. The deeper we look, the more the anomaly behaves like a mirror turned inward. It reflects not just the universe, but the way we interrogate it. If the cosmos around us is uneven, then every clean diagram in our minds must now be held up against the possibility of local distortion. That does not erase the diagrams. It complicates their authority. And for science, that is a familiar wound. Every generation inherits a map, only to discover the coastline was drawn from too few vantage points. The question is never whether the map is useful. The question is whether it has been mistaken for the territory. In the ordinary imagination, a void sounds like absence, but in cosmology it can behave like pressure. Its emptiness changes how matter moves around it. It changes how light arrives. It changes how a distant galaxy seems to sit against the background of expansion. A void is not a hole punched through reality. It is a region where reality is arranged differently. That distinction matters, because if our region lies inside a broad underdensity, then the universe may appear to expand in a way that is locally amplified, not because the laws are broken, but because the stage beneath them is subtly sloped. There is a deep irony here. The emptier the region, the more important it may become. A sparse cosmic neighborhood can act like a lens made not of glass, but of gravity and geometry. It stretches interpretation without touching the light in any obvious way. And because the effect is indirect, it is dangerously easy to miss. One does not notice a slight tilt in the floor until the water in the glass leans against the rim. One does not notice a local anomaly until the universe starts returning different answers to the same question. That is what the Hubble tension feels like now. A question asked twice, answered twice, and not quite the same. If future observations continue to sharpen the discrepancy, the pressure on cosmology will grow in two directions at once. Either we will have to revise the physics governing cosmic expansion, or we will have to revise the way we interpret our own cosmic location. Those two options are not separate in the way they first appear. A new physics solution might still require a new understanding of local structure, and a local structure solution might reveal unknown physics in the distribution of matter itself. The universe, as always, refuses to present its puzzle pieces in neat piles. It scatters them and expects us to notice the pattern in the scatter. This is where the story becomes more than technical. It becomes existential in the quiet, unnerving way only cosmology can achieve. To discover that our region is unusual would mean that the world behind our measurements is not as steady as it seemed. Not just the stars, but the very frame of expansion and distance would have to be treated with new caution. The sky would remain beautiful, but beauty would no longer guarantee familiarity. The cosmos would look less like a fully charted continent and more like an archipelago seen through changing weather. Some islands clear, some hidden, some linked by routes we have only begun to infer. Perhaps that is why this idea lingers so powerfully in the mind. It does not ask for a dramatic overthrow of science. It asks for humility in the face of scale. It asks us to accept that our most elegant models may still be local approximations wrapped around a more textured universe. It asks us to consider that our place in space may be influencing our measurements as much as our instruments are. And once you take that seriously, the universe becomes stranger not because it is less knowable, but because it is knowable only from within its own unevenness. The final unease is that this logic may extend beyond cosmology. If our location can bias our reading of the universe, then position itself becomes a fundamental epistemic variable. Knowledge is not just about the data. It is about the cosmic conditions under which the data are collected. That thought is both obvious and devastating. Obvious, because all observation happens somewhere. Devastating, because the somewhere may be too unusual to ignore. It means there are limits to how far certainty can travel without checking the terrain under its own feet. So we end where we began, but deeper now, with less confidence and more wonder. We began with the possibility that our region of the universe might be abnormal. We end with the recognition that this abnormality, if real, would not merely adjust a parameter in a model. It would alter the relationship between observer and cosmos. It would mean that reality, at least as we measure it, is partly shaped by the local architecture of space around us. The universe would still be vast, still lawful, still ancient, but our view of it would be revealed as more fragile, more conditional, and more haunted by place than we ever wanted to admit. And perhaps that is the truest cosmic lesson of all. The universe does not have to be simple to be magnificent. It does not have to be neatly uniform to be real. It can be uneven, layered, and full of hidden geography, and still produce the laws that give rise to galaxies, stars, life, and thought. we are not diminished by that possibility. We are made more responsible by it, because if our corner of existence is one of the places where the universe's shape is subtly deceptive, then understanding reality means learning to question not just what we see, but where we stand when we see it. So the mystery remains open, breathing quietly in the dark between the galaxies. Maybe we live inside a cosmic anomaly, large enough to bend the story of expansion. Maybe the numbers disagree because our neighborhood is not average. Maybe the universe is telling the truth through a local distortion we have only just begun to detect. Or maybe this is only the beginning of an even stranger explanation, one that waits beyond the models we trust today. Either way, the feeling is the same. We have looked outward and discovered that the first thing we need to understand is the ground beneath our own cosmic feet. This is a humbling landscape to inhabit, one where certainty is provisional and every measurement carries a shadow of doubt. But such humility is not defeat. It is the doorway to deeper insight. Science has always progressed by embracing discomfort, by allowing questions to crack open the veneer of accepted knowledge. The idea that we might live inside an exceptional cosmic neighborhood may unsettle our assumptions, but it also opens a path to richer understanding. It demands new tools, new models, and new ways of thinking about space, time, and observation itself. Imagine the process of cosmology moving forward not as a march toward a final theory, but as a delicate navigation through complex terrain. Each observation is a compass reading influenced by local geology, the hills, dips, and landforms of cosmic structure. The journey is not linear. It loops back on itself, confronting uncertainties, re-examining prior landmarks with fresh eyes. The map grows not by erasing lines, but by adding contours, textures, and layers. In this view, the universe is less a flat chart and more an evolving relief sculpture whose shape we continuously refine. This metaphor extends beyond metaphor. It touches on the philosophical core of scientific knowledge. To know something is to place it within a context of understanding that includes both the object and the observer. If the observer's position in space influences measurements in a non-negligible way, then cosmology becomes an exercise in relational knowledge, a science not only of universal laws but of spatial perspective. The physical universe and the epistemic universe, the universe as it is and the universe as we perceive it, become deeply intertwined. That intertwining raises profound questions about the nature of reality itself. Is the universe's fabric fundamentally homogeneous but experienced heterogeneously because of local structure? Or is that very notion of homogeneity an idealization that obscures real, directional complexity? If our local environment biases the signals reaching us, is there an absolute cosmic truth accessible only hypothetically? Or is knowledge forever entangled with place? These questions hover on the boundary of physics and philosophy, science and metaphysics. In this unsettling borderland, the search for clarity takes on new urgency. It invites us to devise experiments and observations that can discriminate between models of a uniform cosmos and models allowing more uneven, region-dependent expansion. It calls for creative thinking about how large-scale structure and observer location influence light propagation, gravitational dynamics, and cosmic chronometers. It motivates interdisciplinary dialogue between cosmologists, philosophers, and theoreticians to grapple with the epistemic implications. Meanwhile, the broader cultural impact is quietly profound. The idea that we live inside a subtle cosmic anomaly complicates the narrative of humanity's place in the universe. It neither restores ancient geocentrism nor diminishes the Copernican revolution. Instead, it adds a new dimension to our cosmic humility, one that acknowledges the limits imposed by local cosmic geography without undermining the universal pursuit of knowledge. It asks us to balance wonder with caution, curiosity with reflection. This new cosmic humility resonates beyond science, echoing in how we think about perception, knowledge, and existence. Our vantage point shapes what we see, and sometimes what we believe. The universe, vast and mysterious, does not yield its secrets easily. It challenges us to remember that understanding is always partial, that what appears as a universal rule may be a local dialect in the language of reality. To navigate this complexity is to grow closer not just to the universe but to the subtle interplay between observer and observed. So as you carry the weight and wonder of these possibilities with you, remember that the grandest questions often lead us inward as much as outward. The universe may be stranger, more variegated, and more subtle than the maps we carry in our minds, but it remains a source of beauty and awe, an invitation to explore not only galaxies but the borders of knowledge itself. And here, between known and unknown, comfort and curiosity, certainty and mystery, is where the spirit of discovery truly lives. And if this kind of uncertainty pulls at something deeper in you, if the idea that reality might depend on where you stand feels less like confusion and more like invitation, then stay here, at the edge of that question. This is what Beyond the Universe is meant for. Not to give you comfortable answers, but to take you further into the places where understanding begins to shift, where the known dissolves just enough to reveal something larger behind it. The universe remains vast, ancient, and full of unexplored truth. Our place inside it, however unusual or ordinary, shapes the story we read in the stars. And the story, it seems, is just beginning. This story compels us to rethink the very act of observation, not as a passive recording of facts, but as a dynamic conversation between the cosmos and ourselves. Every photon that reaches our telescopes carries with it a history not only of distant epochs, but also of the space it traveled through, an intricate journey shaped by intervening matter, voids, gravitational wells, and the structure enveloping our own local environment. Understanding that journey is as crucial as understanding the source. The universe's narrative is layered with echoes of the place from which we observe it. What emerges is a vision of cosmology that is deeply contextual. It does not discard the elegant frameworks developed over decades of research. Instead, it adds texture and nuance, showing that context cannot be an afterthought. We live inside the universe, not outside. Like a character in a vast novel, our perspective is shaped by setting as much as by plot. The cosmic voids and filaments, the dense clusters and silent expanses surrounding us, color the meaning of every measurement, just as a theater's acoustics shape how an actor's voice is heard. This realization invites a new kind of humility and a new kind of wonder. To accept that our cosmic neighborhood might be an uneven patch in an otherwise smooth universe is not to diminish the laws of physics. It is to acknowledge the intricate canvas on which those laws play out. The grandeur of cosmic evolution, the dance of galaxies, the birth of stars, the emergence of life, all remain true, but our understanding of them deepens when we consider the influence of the cosmic environment framing our view. The ripple effects of this shift go beyond astrophysics and ripple into the philosophy of science itself. It highlights the importance of epistemic humility, the recognition that knowledge comes with constraints, and that assumptions of uniformity, while powerful, must be continuously questioned. It reminds us that every scientific narrative is authored from a particular point of view, no matter how expansive, and encourages us to seek ways of bridging local experience with universal truth. So what lies ahead? Future explorations will combine vast new datasets from deep sky surveys, gravitational wave detections, and precision cosmology experiments with improved theoretical models that incorporate cosmic variance and local structure effects more fully. We will develop sophisticated simulations that recreate not only the universe's global properties, but also the intricate patches in which we find ourselves. These will become laboratories for testing how local anomalies influence our cosmic readouts. Alongside these developments, the dialogue between cosmologists and philosophers will intensify. Conceptual clarity about what can be known, how observation is shaped by location, and what counts as cosmological principle, assumptions will become as crucial as technological advancement. The challenge is not merely to catalog data, but to integrate that data into a coherent understanding that respects both complexity and coherence. In the end, the possibility that our cosmic neighborhood might be an anomaly is not a setback. It is an invitation to deepen our inquiry, to embrace subtlety, to refine our notions of what it means to observe, to measure, to know. It is a reminder that the universe is both stranger and more beautiful than the neat equations printed in textbooks. That mystery is not an obstacle, but the very fuel of discovery. And so, the quest continues, ever onward, ever outward, yet also inward, mapping not only the grand ensemble of galaxies but the contours of our own cosmic home with ever finer precision. Beyond the Universe means pushing these boundaries, listening to the whispers of the cosmos's hidden architecture, and never settling for the comfortable when the mysterious calls. Because maybe the greatest discovery awaits not just in the farthest reaches of space, but in understanding the subtle and profound ways our place shapes the story of everything. The universe is vast, yes, but it is also local, and our position within it is a key to unlocking yet more of its secrets. This is the horizon before us, immeasurable in scale, complex in structure, and filled with questions as vast as the voids themselves. We stand at the edge of knowledge, with the universe expanding not only in space, but in the depth of its mystery, inviting us to look beyond what we thought possible. to see not just stars but shadows, not just light but distortion, and not just certainty but humility. And if that journey speaks to your own wonder and curiosity, then continue that exploration with us at Beyond the Universe, because to grasp the cosmos fully is to accept that sometimes the hardest truths are the ones shaped by where and who we are. If the earlier chapters were about diagnosing the tension, the next must be about living with it. A genuine scientific mystery is not solved the moment it is named. It changes the culture of inquiry around it. Instruments are improved, assumptions are audited, data pipelines are scrutinized, and rival hypotheses are sharpened into forms that can actually be tested. That is how cosmology behaves at its best, not as a court issuing immediate verdicts, but as a long conversation in which each answer must survive contact with the next observation. One of the most important lessons here is that local does not mean small in its consequences. A region spanning hundreds of millions of light years may still be local relative to the observable universe, yet it can shape the inferred expansion rate in ways that ripple through the entire edifice of cosmology. That scale mismatch is part of what makes the problem so fascinating. The universe can hide a major interpretive effect in what looks, at first glance, like a modest deviation from average. If that sounds unsettling, it should, but it should also feel strangely familiar. Human beings are pattern-seeking creatures who routinely overgeneralize from the environments nearest to them. We do it in social life, in culture, in history, and in science. Cosmology merely forces the habit into the open. It says, your sample may not be representative. Your vantage point may matter. Your normal may be parochial. That is not a moral failure. It is an invitation to widen the frame. The most productive response to such an invitation is methodological pluralism. No single measurement, however elegant, should be expected to settle a problem that may involve geometry, dynamics, and location all at once. Standard candles, standard sirens, background radiation, galaxy clustering, weak lensing, and large-scale flow measurements each interrogate the cosmos in different dialects. If the anomaly is real, it may speak more clearly in some dialects than others. Listening carefully means comparing them without forcing premature harmony. This is where the story of modern cosmology becomes especially rich. The field is no longer limited to asking whether the universe expands. That question, once revolutionary, has become the starting point. Now the sharper question is, how exactly does it expand, from where, and relative to what distribution of matter and structure? These are not pedantic refinements. They are the difference between a global law and a local measurement dressed up as a universal one. There is also a psychological dimension to all of this. Scientists, like everyone else, are affected by the emotional weight of their own theories. A simple universe is comforting. A universe in which our measurements may be biased by hidden local structure is less comforting but more honest. Yet discomfort can be productive precisely because it resists complacency. It keeps the intellect alert. It reminds us that elegance is not the same as certainty, and that even a beautiful model can become a trap if it is not tested in hostile terrain. In that sense, the Hubble tension is not merely a crisis, it is a stress test. It asks whether the standard cosmological picture can absorb a serious internal contradiction without collapsing, or whether the contradiction is the first visible crack in a deeper revision. Either outcome would be profound. If the model survives, it will do so because it proved stronger than its critics believed. If it changes, it will do so because reality refused to fit the inherited frame. Either way, knowledge advances. The deeper philosophical point is that universality is never granted, it is earned. We do not simply declare a rule universal because it feels broad enough. We test it across environments, scales, and methods. In cosmology, this becomes especially difficult because the experiment cannot be rerun in a different universe, or from a detached standpoint outside the cosmos. We have one sky, one horizon, one embedded location. The challenge is to infer as much as possible from that singular situation without pretending it is simpler than it is. And so the narrative returns, again, to place. Not place as a poetic flourish, but place as a physical variable. The distribution of matter around us, the history of our local region, and the path of light through that region may all matter more than we once wanted to admit. If so, then every measurement is partly a measurement of our cosmic address. That is an elegant and unsettling idea. The universe may be telling the truth, but not in a way that is independent of where we happen to live within it. What comes next will likely be messier than anyone prefers. Different teams will argue over systematics, selection effects, calibration subtleties, and the statistical meaning of apparent disagreement. Some will insist the discrepancy is overblown. Others will argue that it is the clearest sign yet of new physics or local bias. The public may experience this as confusion. In reality, it is how the frontier behaves. Ambiguity is not the opposite of progress. It is often the price of getting close to something real. There is no shame in not knowing. In fact, cosmology is at its most impressive when it can say with precision, "We do not yet know which explanation is correct." That statement is not failure, it is discipline. It prevents premature closure. It leaves space for the universe to surprise us. And if the cosmos has indeed arranged our neighborhood in a way that distorts our view, then surprise is not a bug in the system. It is the system revealing its own depth, so the horizon remains open. A local anomaly may prove to be the missing piece or merely one piece among several. New physics may emerge. Better calibrations may resolve part of the discrepancy. Both may happen at once. The important thing is that the question has forced cosmology to become more self-aware, more attentive to the relationship between the observer, the instrument, and the environment through which the signal has traveled. That self-awareness is itself a kind of scientific maturity. It means no longer assuming that the broadest story must also be the simplest. It means accepting that even the universe's largest scales may be read through small, stubborn regional effects. And it means recognizing that the path to cosmic truth is not only outward toward distant galaxies, but inward toward the assumptions encoded in every measurement we make. So yes, continue the search, continue the surveys, continue the debate. Continue refining the models until the tension either dissolves or hardens into a new law of nature. That is the work. That is the wonder. And if, in the end, we discover that our own neighborhood was quietly shaping the story all along, then the revelation will not reduce the universe. It will make it richer, stranger, and far more alive than the smoothest version of reality ever could. As this unfolding mystery commands the attention of the scientific community, it reminds us of the inherent beauty of inquiry, the willingness to embrace the unknown and to challenge deeply held assumptions. Each new data set, each refined measurement, is a step deeper into the labyrinth of cosmic complexity. The universe rewards patience and openness, showing that questions often multiply before answers arrive, and that clarity sometimes emerges only through persistent skepticism and creative thinking. The interplay between local structure and cosmic expansion invites technological innovation as well. Future telescopes, both ground-based and in space, will be designed not only to look farther, but to map with greater precision the fine-grained texture of matter distribution. Gravitational wave observatories will provide independent distance measures free from many of the biases affecting electromagnetic methods. Together, these tools will create a multi-messenger view that weaves together geometry, dynamics, and locality in unprecedented detail. Beyond instruments, theory must evolve too. New models must account for how inhomogeneities, cosmic voids, and filamentary structures impact observations. Alternative cosmologies, such as those relaxing the assumption of large-scale homogeneity, gain renewed interest. Even subtle modifications to dark energy or matter properties can be explored to test whether the Hubble tension signals new physics or a more complex cosmic landscape. The dance between theory and experiment is vibrant and ongoing. Importantly, this dialogue illuminates how cosmology functions as a profoundly human endeavor, one where observation, interpretation, and imagination intermingle. The challenges of interpreting data from a single vantage point echo broader themes about perspective, bias, and context that pervade all knowledge. Our place in the universe shapes not only the stars we see, but also the questions we ask and how we understand the answers. Ultimately, confronting the possibility that our cosmic neighborhood is exceptional is an exercise in intellectual humility and wonder. It reminds us that the universe is vast enough to surprise, layered enough to conceal, and generous enough to reward curiosity with deeper truths. As we continue peering outward, we are simultaneously invited to look inward, into the assumptions, methods, and perspectives that shape how we read the cosmos. And so the story moves forward, with unanswered questions as its engine and discovery as its goal. Whether the Hubble tension resolves itself through new physics, refined measurements, or cosmic geography, the pursuit enriches our grasp of reality. We are explorers on a vast and mysterious sea, charting the contours of existence with tools crafted from human ingenuity and humility. The universe, in all its complexity, calls us to persist, to embrace uncertainty as the birthplace of knowledge, to cherish wonder as the catalyst of science, and to recognize that our cosmic address is not a limitation but a gateway. Through that gateway, we glimpse not only distant galaxies but the profound connection between observer and observed, self and cosmos. The adventure continues, as it must, for in the vastness of the unknown, every question answered unfolds countless new inquiries. That is the enduring spirit of cosmology, a voyage without end where the horizon always beckons, and the universe, the ultimate storyteller, awaits our listening. And with that, we find ourselves on the threshold once more, ready to peer beyond, to question deeper and to discover the universe anew, not as a distant abstraction, but as the richly textured home in which we live, measure, and dream. As we stand on this threshold, the importance of interdisciplinary collaboration becomes ever clearer. Cosmology no longer exists in isolation. It draws upon fields as diverse as particle physics, astrophysics, statistics, computer science, and even philosophy of science. Progress depends on the synthesis of ideas and methods across disciplines, each bringing unique perspectives to unravel the tangled threads of cosmic puzzles. Insight often emerges at these crossroads, where rigid boundaries dissolve and fresh patterns take shape. The computational revolution plays a pivotal role in this quest. Advanced simulations now recreate vast cosmic volumes, incorporating complex physics and realistic structures, allowing researchers to test how local inhomogeneities influence observations. Machine learning techniques uncover subtle correlations and anomalies within the deluge of data gathered by surveys. These tools empower us to probe questions once considered out of reach, transforming conjecture into testable hypothesis with unprecedented fidelity. Yet amid this surge of data and models, the human element remains essential. The interpretation of results, the design of experiments, and the articulation of conceptual frameworks all require creativity, intuition, and critical reflection. Science is as much an art as it is a collection of facts, a narrative woven from observation, theory, and interpretation. Maintaining clarity about assumptions, limitations, and uncertainties is crucial to avoid pitfalls of overconfidence or misinterpretation, especially when confronting phenomena as subtle and profound as the Hubble tension. This juncture in cosmology also offers an opportunity for public engagement and education. The profound questions raised about our place in the universe, the nature of cosmic expansion, and the limits of knowledge resonate beyond specialized circles. Sharing the thrill of discovery, the challenges of uncertainty, and the openness of scientific inquiry can inspire curiosity and trust. It invites everyone to participate in the voyage toward understanding, reminding us that the cosmos belongs to all who gaze upward in wonder. Meanwhile, the search for answers continues to push observational ingenuity. Next-generation missions will achieve finer resolution of cosmic microwave background anisotropies, map galaxy clustering over enormous scales, and expand the catalog of standard candles and standard sirens. These observations will refine distance measures, reduce systematic uncertainties, and confront anomalies with ever-increasing rigor. Through this iterative process, the picture of cosmic expansion and structure will sharpen, revealing whether local structures or new physics, or a combination, account for the Hubble tension. It is worth remembering that cosmology is a young science, rapidly evolving and still assembling its foundational framework. The history of science shows that paradigm shifts, those profound recalibrations of understanding, require patience and resilience. The current tension may herald such a shift, or may result in a subtle correction within an established model. Either way, the pursuit embodies the scientific spirit, to follow evidence where it leads, to question even cherished principles, and to embrace the unknown as an opportunity rather than a threat. As we move forward, humility remains the guiding star. The vastness and complexity of the universe resist simple answers, yet that resistance fuels the drive for deeper exploration. Each refined parameter, each resolved anomaly, and each theoretical insight bring us closer to a more comprehensive and nuanced cosmic story. The journey through this cosmic puzzle reflects our broader quest to comprehend the universe, not as a static arena, but as a dynamic, intricate, and ultimately mysterious realm. Recognizing the role of our cosmic neighborhood in shaping observations enriches that quest with new dimensions of meaning. It compels us to see cosmology as a science attuned to context, perspective, and subtlety. Ultimately, the endeavor to understand the Hubble tension and its underlying causes exemplifies the vibrant, ongoing process of discovery that defines science itself. It inspires wonder, demands rigor, and invites collaboration across boundaries of expertise and perspective. In this process, we not only learn about the cosmos, but also about the nature of knowledge and the enduring capacity of human curiosity. So, with anticipation and dedication, we continue onward, charting the cosmos from our local vantage point, aware of its influence and eager to decode its mysteries. The universe is not merely out there, but entwined with us, and through that connection, the story of existence unfolds in ever more fascinating directions. The horizon beckons still, vast and uncharted, and with each question answered and each mystery embraced, we take another step into the grand adventure of understanding the universe and our place within its boundless expanse. If we continue this line of thought, we arrive at a crucial realization. The debate is no longer only about a number, it is about what kind of cosmos we think we inhabit. A tension in the inferred expansion rate is, on the surface, a disagreement between measurements, but beneath that surface lies a deeper argument about uniformity, evolution, environment, and the reliability of our most trusted assumptions. In that sense, the Hubble tension is really a question about the architecture of reality, as much as it is about astronomy. The temptation, when confronted with persistent discrepancy, is to search immediately for a dramatic explanation. New particles, exotic dark energy, modified gravity, these are exciting possibilities, and they may yet prove relevant. But the quieter possibility is often the more difficult one to accept, that our own cosmic neighborhood subtly biases the interpretation of what we see. A modest departure from homogeneity may not overturn the universe. It may simply remind us that every measurement is made from within a landscape, not above it. That distinction matters. A universe with local structure is not a broken universe. It is a textured one. Structure is not an embarrassment to cosmology. Structure is the very reason galaxies, stars, planets, and observers exist at all. The challenge is to distinguish the inevitable presence of structure from the assumption that, on the scales relevant to our inference, it can be ignored. Sometimes that assumption holds beautifully. Sometimes it turns out to be the source of the problem. This is why the next decade of cosmology will likely feel less like a march towards certainty and more like a mapping expedition. The goal will be to chart not only the distant universe, but the observational pathways that connect us to it. How much does matter between here and there matter? How do voids, flows, and superclusters distort the signals we use to infer cosmic history? Which discrepancies survive once those effects are included at higher precision? These are the kinds of questions that transform attention into a research program. There is elegance in that transformation. Science often advances by taking an inconvenient anomaly and turning it into a framework for better understanding. What begins as a mismatch can become a diagnostic tool. What begins as a problem can become a method. The Hubble tension, whatever its ultimate explanation, has already forced the community to improve calibrations, revisit error budgets, and interrogate the reach of foundational assumptions. That alone is a meaningful gain. It is also worth noting how this issue reframes the word average. In everyday speech, an average sounds neutral, even objective. In cosmology, however, the average can be a theoretical ideal rather than a directly observed fact. We infer it by sampling a universe that is both vast and uneven. If our sampling location is unusual, then the average we reconstruct may be subtly shifted. This is not a flaw in mathematics. It is a reminder that statistics always live in the real world, and the real world has geography. Another important lesson is that precision without context can be misleading. Modern cosmology is wonderfully precise in many respects, but precision alone does not guarantee correctness if the underlying model is incomplete. A highly accurate ruler is still problematic if it is used to measure the wrong thing. That is why the interplay between data quality and conceptual framing is so central here. The question is not only whether we can measure more carefully, but whether we are measuring the right quantity in the right way. From this perspective, local cosmic structure becomes not a nuisance, but a possible key. If we live in a region that is underdense, overdense, or dynamically distinct from the cosmic mean, that region becomes part of the inference itself. The universe may not be hiding a secret so much as presenting us with a context-dependent answer. Context-dependent answers are harder to summarize, but they are often truer to reality. This is one reason the story has such intellectual depth. It crosses the boundary between empirical science and philosophical reflection without losing rigor. We are asked to consider how much confidence we can place in measurements made from a single embedded point in spacetime. That question is technical, yes, but it is also profound. It touches the limits of perspective itself. What does it mean to know the whole when we can only ever stand within a part? Yet the answer to that question is not despair. It is collaboration, refinement, and persistence. By combining independent methods, cross-checking assumptions, and building increasingly sophisticated simulations, cosmologists are gradually reducing the space of possible explanations. Some paths will narrow, others will open. That is how mature science behaves, not by eliminating uncertainty, but by organizing it into something tractable. And so the journey continues with a renewed sense of purpose. Whether the eventual resolution lies in local inhomogeneity, revised systematics, new physics, or some interplay among all three, the process itself is already reshaping the field. It is making cosmology more self-aware, more careful, and more complete. It is teaching us that the universe is not only something to be described, but something to be interpreted from a situated viewpoint. Perhaps that is the deepest lesson of all. We are not detached spectators of cosmic history. We are participants in it, embedded in a region that may influence how the story is read. The act of measuring the universe is therefore also the act of locating ourselves within it. That does not diminish the grandeur of cosmology. It intensifies it. And so we continue, not with certainty but with disciplined curiosity, not with final answers, but with sharper questions, not with the illusion of standing outside the cosmos, but with the humbling knowledge that our place inside it matters. The mystery remains, but now it is illuminated from a new angle. So we arrive not at a conclusion, but at a threshold, the kind of threshold that does not separate knowledge from ignorance, but one layer of understanding from another. The universe has not contradicted itself. It has simply revealed that what we thought was stable may depend more on where we are than we ever expected. If the expansion of the cosmos is being read from within a region that is not typical, then every number we trust carries a shadow, not an error, but a condition, a quiet dependency on location, structure, and unseen geometry. The universe does not become less real because of this. It becomes more precise and more difficult to interpret, and that is the deeper shift. Cosmology is no longer just the study of what the universe is doing. It becomes the study of how our position inside it shapes what we think it is doing. The observer is no longer a neutral point. It is part of the equation, embedded, influenced, and inseparable from the measurement itself. If that is true, then the question is no longer only, how fast is the universe expanding? The question becomes, from where is that expansion being measured? And how much does that place matter? Because somewhere out there, beyond the galaxies we can map and the background radiation we can decode, the larger structure continues, silent, uneven, and patient. And within that structure, our position may not be wrong, just incomplete. And if we are standing inside one of those incompletions, inside a region that subtly bends the story of the cosmos, then the most unsettling possibility is not that the universe is broken, but that we have been reading it from a place that was never meant to explain the whole.